Okay, we're back, and we're back on to Chapter 52. Chapter 52, Selection and Erection of Wiring Systems. Okay. Let's get there. Right. I said in the previous video, this is going to be a couple of videos long, I think. We've got types of wiring system, selection and erection of wiring systems in relation to external influences, current carrying capacities of cables, cross-sectional areas of cables, voltage drop, connections. Right, so wiring system includes well, you should know what a wiring system is, but it consists of the chosen methods of containment, the chosen conductor sizes, and all that stuff. So we start off with 520 introduction, scope, okay. General consideration shall be given to the application of the fundamental principles of Chapter 13, and it applies to cables and conductors, their connections, terminations or joints, their associated supports or suspensions, and their enclosure or methods of protection against external influence. Okay. 521. Types of wiring system. The requirements of regulations 521.1 to 201 do not apply to busbar and powertrack systems covered by regulation 521.4 because they're a specialist type of system. 521.1. The installation method of a wiring system in relation to the type of conductor or cable used shall be in accordance with Table 4A1 of Appendix 4, provided the external influences are taken into account according to Section 522. So we can quickly peek this at Appendix 4, Table 4A1. It's a very simple table. It actually looks like this. We're going to use a lot of Appendix 4 through Chapter 52. Just a little heads up there. Alright. Okay, Appendix 4, 373. We go through there. Yeah, it's got to be quite a way in there. Right. Table 4A1. 4A1. Page 385 if you're looking for a page number. Right, schedule of installation methods in relation to conductors and cables. I mean, just look at it, it's fairly obvious really. This tells us conductor and cable methods, be they bare conductors, so unsheathed, uninsulated conductors, or a non-sheathed cable, such as a single that you'd put in a trunk in, or a sheathed cable, whether it be single or multi-core. So if you look at the methods of installation along the top, you can see, well, if you've got a bare conductor, which has no sheathing and no insulation, you're not going to install it without fixings, or clip direct, or in a conduit, or in a trunking. The only method you can really use is, as illustrated here, on insulators. Similarly, if you had non-sheath cables, singles, you wouldn't put them clip direct. You'd have to put them in a conduit system or a trunking system, a wiring system, and so on. The rest of the table is fairly obvious when you think of it, isn't it? The next page is Table 4A2, which looks like this. Here. It starts looking like that. It's quite a long table. Now, I'm going to come backwards and forwards to here, but let me just go back to 52, and I'll just get to here in a minute. 521.2. The installation method of a wiring system in relation to the situation concerned shall be in accordance with Table 4A2 of Appendix 4. Other methods of installation of cables and conductors not included in Table 4A2 are permitted, provided they fulfill the requirements of this chapter. So there's all these illustrations of the recognised methods of installation. So they're all numbered down the left, 1, 2, 3, 4, blah, 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 so you can reference them quite simply, with an illustration, a description, and then there's a reference method. The reference method is very important because the reference method we'll use later on when we use rating factors for grouping and we look at cable sizing, current carrying capacities. They're all determined by the reference method. A cable's current carrying capacity is dictated by its ability to give off heat under load, and what restricts that are factors such as grouping and factors such as the method of installation. So being able to find this reference method is very important. So for example, if I was to have a cable and I was to have it, let's say a multi-core cable in a wall, and then just chased over, chased down a wall and then plastered over, that's illustrated in reference method 57 and 58. Single core or multi-core cable, direct in masonry, having a thermal resistivity not greater than 2 Kelvin per meter watts. So that's chasing a wall, putting a cable in, plastering it over. That's the reference method C. Now, if you kind of study these reference methods, what you'll notice a trend, and the trend is the harsher methods of installation come up as reference method A. So these methods either are in thermal insulation or in thermally restrictive areas, such as these illustrated, such as these here, thermally insulated walls. Okay, these are A. Now these are okay, but do note that these reference methods do specifically mention that one part of the run is touching the inner side of the wall. That's very important. That's a thermally conductive surface. If that wasn't in contact with the thermally conductive surface, it would be knackered and would be derating it a great deal more than that. But you'll notice as you look through this table and you just kind of study them, that A's are bad, B's are better, and C's are much better. Okay, and that's the trend that we need to pick up. And we can actually just to kind of complete that, let's go to a cable. Let's go to a random cable in Appendix 4. And you can see how that relates to cable's current carrying capacities. So if I look at, what am I looking at here? Let's look at a cable that we can kind of relate to. Well, okay. I mean, if we go to table 4D5, which is the twin and earth flat profile cable, page 409 in the 18th edition. There are some reference methods. I mean, we've just mentioned A, B, and C. There's actually, at the end of the table, there's also another little part, which is 100, 101, 102, which is referring to specifically twin and earth flat profile cables. But you can see, as you look at this table on 409, so page 409, it should look a bit like that kind of layout. If you're looking at anything else, you've got it wrong. Table 4D5. So, as I look at a conductor here, let's look at the 2.5mm cable, very left column. I then have, going to the right from that, numbers 21, 17, 21, 13.5, 27 and 20. Those are the current carrying capacities determined by the method of installation above. So method 100, a 2.5 can carry 21 amp. 101, 17 amp and so on. And we said C was the better way to install the cable, and you can see actually 27 amps is reference method C here, and that is the best way to install a twin and earth. Surface clip direct, but also we noticed that the cable being chased in the masonry, plastered over, was also reference method C. So whilst it's called clipped direct, don't confuse that. Chasing in a wall, plastering it is also technically clipped direct. So that can carry 27 amps. But if we were to change the method of installation, such as reference method A, putting in a conduit, you can see that drops down to 20. So the method of installation is important because it then translates to the cable's current carrying capacities later on. I'm going back now to chapter 52. So that then mentions busbar power trunking systems. We don't do much with them in the regulations. There's a special appendix which just mentions them, and it tells us to refer to the manufacturing and specific design criteria. The closest thing you'll have regards to this in your exam, for example, would be asking the BS numbers, really. That's probably as far as it will go. Power track systems won't be touched. It's a bit of a, not a specialist, but it's just a bit of a manufacturer-specific requirement there. We then have 521.5, which mentions the ferromagnetic enclosure So the conductors of an AC circuit installed in ferromagnetic enclosures shall be arranged so that all line conductors and the neutral, if any, and the appropriate protective conductor are all contained within the same enclosure. Where such conductors enter a ferrous enclosure, they shall be arranged such that the conductors are only collectively surrounded by ferromagnetic material. These requirements do not preclude the use of an additional protective conductor in parallel with the steel wire armouring of a cable where such is required to comply with the requirements of the appropriate regulations in Chapter 41 and 54. Okay, I've seen that as a question actually, asking what one cable can actually go on its own through a ferromagnetic enclosure, and it's the additional earth on like an armor or something like that. All the live conductors and the neutrals and everything, as it says there, should go through the one point. This is all to challenge the theory and the theory of the eddy currents that can circulate when you have this kind of thing. You have the electromagnetic field created, you have the voltage created with changing and switching operations. Same here, and you end up with what you end up with is circulating eddy currents on the spot. Okay, so that's the theory of that. I know that there's been some skepticism on that. I know that John Moore did a video putting a thermocouple on there, put quite a heavy current. I think it was 100 amp or 200 amp or so. Didn't really prove to raise the temperature much, but I also know that some thermographer colleagues of mine, I'll try and remember to put a little quick photo of it here, have captured this eddy current event in a thermal imaging survey. So yeah, it's one of those things. We know the theory, but we don't often see the actual practice of it. But who knows? We then have, what do we have? Conduit, ducting, trunking, and tray. That's fairly boring. Multi-core cables to that will wait for 528. Okay. Let's go down to 521.10. Installation of cables. Non-sheath cables for fixed wiring shall be enclosed in a conduit, ducting, or trunking. This requirement does not apply to a protective conductor to 543. This is a protective conductor running on its own. Non-sheath cables are permitted if the cable trunking system provides at least a degree of protection of IPXXD or IP4X, and if the cover can only be removed by means of a tool or a deliberate action. So this is something I've often picked up on a periodic inspection and in the ITR. So if you have non-sheath cables, so you have singles in a trunking or in a conduit or something, it says there with the installation of cables, if they're in a trunking system, it must be to IPXXD or IP4X. So think about whenever you go, whenever you find a trunking, you see there's a 20mm hole in it, and you're like, that's bad. You want to know a regulation. Well, there's one right there. Okay, it must maintain IP4X if it's got non-sheath cables. Non-sheathed means singles without another sheath. So when you have an armor, you take off the armor and then another black sheath. With a twin and earth, you have the grey sheath. Singles don't have a sheath. They're just browns and blues on their Todd. So we need to have IP4X or IPXXD. And the lid, it says tool, but it also says a deliberate action. So if the lid falls off, or if the lid, can come off by accident or by default by vibration, then that's also inappropriate. So you've got to kind of think about that. Okay. .202, which is the slide here. Now, wiring systems shall be supported such that they will not be liable to premature collapse in the event of a fire. I did a YouTube video talking about this back in pre-18th Amendment 3, when it was just for escape routes, which covered the whole history to the regulation, the retrospective problem, and all that stuff. But all they've done really in this is they brought it forward, so it's no longer just escape routes, it's in all wiring systems. So any wiring system where you're installing a cable high up over a ceiling, etc., if you're above a ceiling and that ceiling is not a fire barrier, so in a fire condition it's not expected for that to, the fire to be guarded, the wiring to be guarded from the fire, the fixings and everything can soften and the cables can collapse and can fall down, and firefighters can become entrapped in a firefighting event. So you know, this isn't new. We've had this going around for a while now, but they've just broadened the scope to total scope basically instead of escape routes. But there's some good manufacturers making some very useful clips and trying to kind of keep us ahead with this. And it hasn't got to be every fixing. It's got to be sufficient to keep them up in the air in a collapse condition. So, you know, suitable risk assessment on the fixings that you need is all that all the approaches you really need for that. Okay, we then have 522, which is selection and erection of a wiring system in relation to the external influence. So what are these external influences? Well, that one's obvious, isn't it? So the first thing you'll see is ambient temperature, 522.1. And it says a wiring system shall be selected and erected so it is suitable for the highest and lowest local ambient temperatures, and so the limiting temperature in normal operation from 52.1 and the limiting temperature in case of a fault, 43.1, will not be exceeded. So limiting temperature in case of a fault we saw when we did protection against overcurrent. The 52.1 table is actually on page 142 in three or four pages time, telling you the limiting temperature of a thermoplastic is 70 degrees at the conductor, thermosetting 90 degrees at the conductor, MI is 70 degrees at the sheath. Okay, seen this as an exam question recently. Okay, so remember that limiting temperature of your conductors. You'll also notice the AA there with the ambient temperature. This is where it's probably a good time to look at Appendix 5. Now if we go to Appendix 5, this is the external influence category area. So anytime you see something that says an external influence, then Appendix 5 may help. So that's on page 445. It's the Appendix 5 classification of external influences. I'll have a quick swig while you get there. Okay. Now, the classification of external influences is broken into three categories of external influences. We call them the general categories. They are A, B, and C. And as you can see, A is environment. That's what this is. This is a environmental external influence. So it's A. B is utilization. That's how it's used. Who uses it? How often it's used. And C is construction of building. You then have second letters actually referring to a specific. So we have A as it's environmental, and there's going to be another A, and that is obviously temperature. Okay, but if we turn the page, it'll start to make more sense. So turn the page to 446. You can see a concise list here. We have A, and then it shows us AA is ambient. And then if you put your finger down, AA1, AA2, AA3, you have a variety of ambient temperatures, a range of them. Okay, so if I was to say the classification of external influence for an ambient temperature of plus 5 degrees C, plus 40 degrees C, you'll be going, okay, and you'd be going AA5. So just reference to that is fairly obvious. Once you understand that there are three columns there. There's AA for ambient, and then there's AF for corrosion. Okay, then you have AM for electromagnetic. Going across, there are three separate columns. People often have trouble understanding the layout of this. For example, something we'll see very soon is flora and fauna, and they'll start looking for flora and fauna, and it's in the middle of the page, so it's actually AK is flora, and AL is fauna. Okay, so familiarize yourself with how that works. If we get down to, for example, water, AD, you can see that there are then negligible, AD1, drops, AD2, sprays, AD3, splashes, AD4. When we think of water, though, we don't think of AD, and we think of IP ratings. But this is the external influence category. This will then refer you to an IP rating, and you can see that if you turn into the actual guidance that's with this appendix. So the next page shows you the environmental guidance. If you turn the page and you go to AD, you'll then see when it gets to AD, negligible, free falling drops, sprays, splashes, jets, it shows you the equivalent IP codes. So the IP codes are here in the book, referring to the external influence category. So quick question then, what is the external influence category that is considered for ambient temperature AA as normal? Okay, is it AA1, AA2, AA3 or AA4? Well, you go to the external influence category of ambient temperature AA, you look in the guidance AA1, AA2, AA3 and AA4, and only one of them is suggested as normal in the characteristics required section, and that's AA4. Okay, now if you have trouble following that, then just maybe go backwards and just listen to how I found it, but otherwise let me know. But this is also a previous kind of question that I've seen before, the recommended guidance. So if I was to say what is the what external influence category requires IP, I don't know, 4x, you can then say, well, that's not liquids, that's solids. So you go to AE. And when you go to AE, which is the solids, you can see the recommendation of IP4X belongs to AE3. Okay, so it's just understanding how the external influence categories bounce around like that. Also, don't forget that there are 3 general categories: environment, building, and utilization. That means they may have a question, and the answer is obviously the one that's not an external influence category. That may be something I see a lot as well. So I'm going to go back now to chapter 52, section 522. That just introduces you to external influence categories, but you can go back to them anytime you want to. You know where they are now. And if you are tabbing, you can always tab that as Appendix 5, external influences. We then have external heat sources, 522.2. This is very simple. It says, in order to avoid the effects of heat from external sources, one or more of the following methods, or an equally effective method, shall be used. So we'll shield the cabling from the heat source. We'll place sufficiently far from the source of heat. We'll select the system with due regard to the additional temperature rise that may occur, or local reinforcement or substitution of insulating material. Now, the common examples you'll see for this would be in luminaires, where you'll open up a luminaire and there'll be some extra sleeving in there to apply over your conductors, heat-proof sleeving. Or you may have a luminaire with a, if you still work with these days, there'll be a ballast in there, and there'll be a metal shield in there, and you run the cables the other side, especially with through wiring. So the manufacturers do accommodate heating effect. They do find ways for us to install them. If we install to the manufacturers, then there shouldn't be a problem. We have AD, presence of water, or high humidity AB. A wiring system will be selected and erected so that no damage is caused by condensation or ingress of water during installation, use, and maintenance. The complete wiring system shall comply with the IP degree of protection relevant to the particular location. Where water may collect or condensation may form in wiring, provision shall be made for its escape. That's why we have these drain holes on these IP44, IP54 socket outlets that we buy. The drain hole is there in case there's a potential humidity or water buildup in there. Ideally, it won't happen. But, Okay, we then have solid foreign bodies, AE. This illustration just shows you how IP6X is tested in the laboratory. That's all this is showing you, okay? Wiring system shall be selected and erected so as to minimize the danger arising from the ingress of solid foreign bodies. The completed wiring system shall comply with the IP degree of protection relevant to the particular location. Now, we most often have to consider moisture with regards to swimming pools, bathrooms, outside installations. We don't often have to compromise for solid foreign bodies other than the IP2X, IP4X, mainly because the moisture consideration has covered it. But there are some circumstances, such as, flower silos or wood workshops, where there's excessive amounts of dust, or excessive amounts of debris and material in what is quite a dry environment. So the equipment may not be selected with any IP consideration at all when it should have been. So, always think about the risks of, solid particles falling onto the electrical equipment when you select it and you erect it. We have AF, presence of corrosive or polluting substances. Where the presence of corrosive or polluting substances includes water, is likely to give rise to corrosion or deterioration. Parts of the wiring system likely to be affected shall be suitably protected or manufactured from a material resistant to such a substance. Dissimilar metals liable to initiate an electrolytic action should be placed into contact with each other, or should not be placed into contact with each other, unless special arrangements are made to avoid the consequences of such a contact. Two metals, two resistivities in contact, you end up with this connection which can become quite corrosive. Impact. This is actually a picture that I took from a race course that had just been rebuilt, and this was about a month after it had been built. Hostess trolley banging into the cable. It just came out of the ground and fed a socket outlet. Wasn't very good. Impact then. So this is another external influence. Wiring systems shall be selected and erected so as to minimise the damage arising from mechanical stress such as impact, abrasion, penetration, tension or compression, both during installation, use or maintenance. In a fixed wiring installation where impact or medium severity AG2 or high severity AG3 can occur, then protection will be afforded by mechanical characteristics of the wiring system, heavy duty steel conduit as an example, or the location selected, move it, or provision of additional local or general protection against mechanical damage, additional barriers or additional guards. For example, you get that kind of thing in a cattle shed, wouldn't you? Or any combination of the above. The degree of protection of the equipment shall be maintained after installation of the cables and conductors. A cable installed under a floor or above a ceiling shall be run in such a position that it is not liable to be damaged by contact with the floor or ceiling or their fixings. A cable passing through a joist within a floor or ceiling construction or through a ceiling support under the floorboards will be installed at least 50mm measured vertically from the top or the bottom as appropriate of the joist or the batten. So you're going to go through the joist, you're going to go 50mm down or 50mm up. So if a nail is driven down or screwed up, then you're not going to hit the cable. Or you'll comply with 522.6.204, which is regarding a salve cable. Now here obviously we have an earth conduit, and here we have the safe plates. These are all possible solutions as well. Don't forget, here we're not talking about span, depth, diameter, and proximity to each other. That's all an approved document M and other building regulations. Okay, this is just about protecting the cables from damage. We're not talking about the building structure here. Cable installed in a wall or a partition at depth of less than 50mm from the surface of the wall or the partition. So it's in the wall and it's less than 50mm from one of the sides. Shall be installed in a zone within 150mm from the top of the wall or within 150mm of an angle formed by two adjoining walls. Where the cable is connected to a point, accessory or switchgear on any surface of the wall or partition, the cable may be installed in a zone either horizontally or vertically to the point, accessory or switchgear. Like that. Where the location of the accessory point or switchgear can be determined from the reverse side, then a zone is formed on one side of the wall of 100mm thickness or less. A partition of 100mm thickness or less extends to the reverse side. So it's saying if you've got a thin wall, it may apply to both sides. Or you'll comply with 522.6.204, which we'll refer to self in a bit. We need RCD protection for these cables. That's protection against, impact, I guess. 203. Irrespective of its buried depth, a cable is concealed in a wall or partition where the internal construction of the wall is metallic. Other than metallic fixings such as nail screws and the like, then it will be provided with additional means of protection such as an RCD, or it will comply with .204, which is again a wiring metal system or cell. So .204 is the solution, the alternatives. So the alternatives are earth metal covering, earth conduit, earth trunking, additional mechanical protection, or itself. So with your average twin and earth cable, you've got to go greater than 50mm in the wall. Otherwise, you've got to go in the zone with an RCD. Now that means that if I'm greater than 50mm in the wall, I can go in any direction I want. From both sides, 50mm from both sides. It also means if I'm running an earthed steel conduit, I can go any direction I want. Because if I hit it, I hit earth first. And the reason I'm saying that is because I may have seen questions like that. Alright, asking you that. You have to go in the zones if you're less than 50mm with an RCD. And your cabling is not in an earthed conduit, not with an earth sheath. It's not of a cell cable or anything else that's in 522.6.204. Okay. Alright, moving on to 522.7 is vibration. The wiring system supported by or fixed to a structure of equipment subject to vibration of medium severity, known as AH2, or high severity, AH3, should be suitable for such conditions, particularly where cables and cable connections are concerned. For the fixed installation of suspended current using equipment such as luminaires, connections shall be made by cable with flexible cores. When no vibration or movement can be expected, cable with non-flexible cores may be used. So, flexible conduit is used mainly for this purpose. From the fixed wiring to the motor. Just there, not the whole thing, just there, really. And it's then saying that if we're going to have luminaires or anything else that might be subjected to movement, vibration, then they will be of a flexible type instead of a solid type. Okay. And that takes us to AJ, other mechanicals. Others, okay. It will be selected and erected to avoid during installation, use or maintenance damage to the sheath or insulation of cables and their terminations. That's achieved by capping and other solutions. Capping only protects cables during installation process when you have the plasterers and other workmen around your installation. You've got to protect it. Where buried in the structure, a conduit system or cable ducting system other than a pre-wired conduit assembly, it will be completely erected between access points before any cable is drawn in. Okay, because you can have sharps or you can have bits of cable snagged. So the wiring system must be fully erected before you install any cabling into a conduit system. The radius of every bend in a wiring system shall be such that the conductors or cables do not suffer damage on terminations and are not stressed. Bending radius is a very big problem because a lot of electricians just don't understand bending radius. They often put cables in to look neat, and it is a bit of an issue. These same race course that I am familiar with, but this is a load center that then feeds two distribution boards, and you can actually see the huge cables here, and the bend is like returning. And what they did is to actually hold these cables in place. There's two zip ties holding these two loops together in this position, but these are actually off the deck. They're floating in the air. And when I first inspected this, the bottom of this board had started to buckle in and twist. There's so much force on that gland. They haven't fixed it, obviously, but yeah. So that's an excessive bending radius there. Okay, the rest are fairly no sharp edges. Means of fixing, yeah, that's fine. Alright, 5229. Presence of flora or fauna. Oh, sorry, flora, which is mould or mould growth, is AK. This is plant life. I've experienced this working in a garden nursery once where a load of ivy crawled into the trunking and it started to twist all around the cables and get everywhere. So plant life has to be trimmed back and kept under control. Then you have fauna. So you have hazard AL2. It will be selected as with the suitable mechanical characteristics. So if you're like in a caravan park and you've got this little twin and earth feeding your shed, then this needs to be replaced with an armoured and maybe installed in a way that's going to obviously avoid any rodent or pest impact. Similarly with I've also seen street lights or lampposts filled with ants nesting, and they can be detrimental to the wiring in those as well. So you've got to select a suitable wiring system, etc. Okay. To finish this off though, we've got, what else have we got here? Ultraviolet radiation. So we've got to consider our cable types, and we've got to consider our cable's exposure to the sun. Twin and earth cables, not very good regards to solar loading. Seismic effects. Earthquakes aren't too common, but it might be seismic effects such as, a bridge or road movement, or it could be the railway that you're adjacent to, and there could be some vibration. So you've got to consider, if there's a bit of flexibility in the building construction, or if there's a bit of vibration, you've got to assess for that risk with your wiring system choices. It might be that rigid metal conduit system is going to put some stress on it. Movement of air. Nature of process of stored materials. There's a risk of ignition and fire there. That refers to chapter 42. Or section 422 specifically. And building design. Okay, that takes us to 523. Current carrying capacities of cables. And that really is going to be another video, because that's where we start talking about cable selection processes. Cable calculations. So we'll stop this video here. So we've talked so far. What we've talked about is types of wiring systems and the external influences that we have to consider when selecting our wiring systems. That's what we've done so far. Selection of wiring systems. In the next video, where we go to 523, still chapter 52, but 523, we'll look at the sizing of the cables, live conductors specifically. The current carrying capacities of cables. In the next video. I'll see you then.